A particle moves according to a law of motion where s is equal to f of t, which is the position function, and t is greater than or equal to 0, where t is measured in seconds and s is in feet. So the position function f of t is equal to 0.01 t to the fourth minus 0.04 t cubed. What we want to do is we want to find the velocity at time t. So the velocity function is the derivative of the position function. So if we take 4, multiply it by 0.01, then we're going to get 0.04 t to the 4 minus 1, so that's t to the third power, and then minus 3 times 0.04 becomes 0.12, and therefore that becomes t squared. So therefore that's going to represent the velocity function. In part B, we want to find out what is the velocity after 3 seconds. So we want to find v of 3. So we're going to plug in 3 in for t into the velocity function. So 0.04 times 3 cubed minus 0.12 times 3 squared gives us 0. And therefore that is 0 feet per second. Okay, now the next question it wants to ask us is, when is the particle at rest? Well, the particle is at rest when we know that v of t is equal to 0, or the velocity function is equal to 0. So if we take our velocity function, which is 0.04 t to the third power minus 0.12 t to the second power, and we set that equal to 0. Okay, now both terms, what they have in common is 0.04 and a t squared. So we can factor out 0.04 t squared, and then what's left is t minus 3, and that is equal to 0. So that means we have 0.04 t squared, which is equal to 0, which tells us that if we divide both sides by 0.04 and take the square root of both sides, we know that t is going to equal 0. Or we have t minus 3, which is equal to 0, so therefore t is equal to 3. So therefore the particle is at rest when t is equal to 0 seconds or 3 seconds. Okay, the next question, it says, when is the particle moving in the positive direction? So in order for us to determine when it's moving in a positive direction, that means when is the velocity function going to be greater than 0? So if we take a look at this part here, that means that function tells us when it's 0.04 t squared times t minus 3, and when is that greater than 0? So if we take a look at the number line here, we know that we have a region at 0, because that's one of the seconds here that we have, and then there's another one at 3. So if we take a look at region 1, region 2, and then region 3, okay, let's plug in a value. In region 1, we're not going to have a time that's going to be negative, so we're not going to worry about region 1, so we don't have time that's going to be in a negative value. If we take a time between 0 and 3, let's say that in region number 2, we can let t equal 1. So if we take 0.04 times 1 squared times 1 minus 3, is that going to be greater than 0? Well, it's going to be multiplied by -2, so therefore it's going to be false in this region. And then we're going to go to region number 3. So if we take a value where t is equal to 4, let's plug it into the velocity function. So 0.04 times 4 squared times 4 minus 3. Regardless of what we get, we know we're going to get a positive number, which is going to be greater than 0. So we know it's true there. So the particle is going to be moving in a positive direction for when t is greater than 3. So when it's greater than 3, okay, now we want to find the total distance traveled during the first 8 seconds. So that means we have 2 intervals here. We're going from 0 to 3 and then from 3 to 8. So the intervals are going from 0 to 3 and then 3 to 8. And then we're going to need the position function, which is the original function. So recall that f of t, or s of t, is going to equal 0.01 t to the 4th minus 0.04 t cubed. So what we want to do is we want to find, okay, the first interval, which is the distance of f of 3 minus f of 0. So if we plug that in, if we plug in 3 into the position function, that's 0.01 times 3 to the 4th minus 0.04 times 3 to the 3rd power minus, well, if we plug in 0 for both of those, it's just going to give us 0. So therefore, if we plug in 3, we end up getting negative 0.27 minus 0. So therefore, the distance there is positive 0.27. Okay, and then we want to find the distance from 3 to 8. So we want to find f of 8 minus f of 3. So we have 0.01 times 8 to the 4th minus 0.04 times 8 to the 3rd power. And we found out that f of 3 was equal to negative 0.27. So therefore, that becomes 20.48 plus 0.27. And that is equal to 20.75. So therefore, the total distance is equal to 0.27 plus 20.75, which is equal to 21.02 feet. Okay, so now what we want to do is we want to be able to draw a diagram. So what we're going to do is let's go ahead and draw a diagram here. All right. Okay, so we know we have 0, and this is the position function. So what do we know when t is equal to 0? Well, we know when t is equal to 0, we know s is equal to 0. So here is our point. Okay, and then what happens when t is equal to 3? Well, when t is equal to 3, the position was at negative 0.27. So that means it's going to start going backwards first. So here is that point. Okay, and then if we plug in t, which is 4 seconds, well, that brings us back to the position function. So that would be there. And so we can see here that here is the position function. This is the direction. Okay, and then we determined that when t was equal to 8, the position function from above gave us 20.48. So therefore, there is the drawing of our function. Okay, now what we want to do is we want to find the acceleration at time t and after 3 seconds. So recall that the velocity function is equal to 0.04 t cubed minus 0.12 t squared. So if we want to find the acceleration, that is finding the derivative of the velocity function. So 3 times 0.04 gives us 0.12 t to the second power. And then 2 times negative 0.12 gives us negative minus 0.24 t. And so now what we want to do is we want to find the acceleration after 3 seconds. We want to find out what is a of 3. So we're going to plug in 3 in for t into the acceleration function. So we have 0.12 times 3 squared minus 0.24 times 3. When we multiply that out, we get 0.36, and acceleration is in the units of feet per second squared. So now the next thing we want to do is we want to be able to graph the position, velocity, and acceleration functions for t being in between 0 and 8. So let's first graph our position function, which is 0.01 x to the 4th minus 0.04 x cubed. And then our velocity function is 0.04 x cubed minus 0.12 x squared. And then our acceleration function is 0.12 x squared minus 0.24 x. Okay, so let's go ahead and put in here. So what we're going to do first is we're going to see what happens between 0 and 8. So we have, let's say, -1, and then we have 8. Or let's make that 9, just so we can see that a little bit. Okay, so there's some stuff going on here, and so we might need to look at 2 graphs because we want to see what's going on over here. So let's first take a look at what's happening between -1 and let's say 5, so between 0 and 4. And then we can say, okay, let's go to negative 0.5 for the y-axis, and then we'll go to 1, just so we can see what's happening. So here we can see a better, clearer picture of what's happening between 0 and 4. So let me go ahead and copy that here. So we can see what's happening between 0 and 4. Okay, and then we're going to go all the way to 8. So let's take a look at what happens from 4 to 8. Okay, so let's just go from, let's say, negative 1 and let's just take a look at what happens when we go to 20. And we're going to go from, let's say, 3 to 9, because we want to see what's happening between 4 and 8. So therefore, we can see what's happening between 4 and 8. So it just gives us a better picture as to what's happening with these functions. Okay, so let's see here. So in the first graph, we know that this graph is in between 0 and then 4. And then this graph is in between 4 and 8. Okay, and then recall that the red is the position function. And the blue is the velocity function. And the green is the acceleration function. So now that we have this information, now we can find out when is the particle speeding up and when is it slowing down. Well, recall here that the particle is speeding up when the velocity and the acceleration have the same sign. So that means the particle is going to speed up when the velocity and the acceleration have the same sign. So if we take a look at between the intervals 0 and 2, okay, we can see that the velocity function in blue is below the x-axis, which is negative. And we can see that the acceleration function between 0 and 2 is also below the x-axis, which is negative. So both of those are negative. So we know it's going to occur between 0 and 2. And then also, if we take a look at 3 and greater, okay, if we take a look at 3 here, so 3 and greater, we can see that the velocity function is positive, and we can see here that the acceleration is positive. And you can see here that it continues. So it continues all the way above the x-axis. So you can see it's continuing here for the velocity function, and then there for the acceleration function. So that means when t is greater than 3, we also know that the velocity and acceleration are both positive. They both have the same sign. So therefore, it's speeding up during those times. Now, it's slowing down when the velocity and acceleration have opposite signs, and that is in between 2 and 3. So if you look here between 2 and 3, this velocity function is negative. It's below the x-axis, and the acceleration is above. So therefore, we can see that it's slowing down when they have opposite signs, and that is when t is in between 2 and 3.